sine of pi over 2 is equal to 1. Actually, I should have switched that up and put in 1 instead of pi over 2, but live and learn. But you kind of see where the idea was going.
Okay. And then, some Ron's question.
Mm-hmm.
It has a and u both as 8, which is 2 square root of 2.
Mm-hmm.
So, I mean, I don't know, I'm just bad at radicals, but I'm having problems doing the work. Because,
For which problem?
this problem of
Is it
the homework.
is it plus?
Yeah. Sorry, what?
Is it a plus between them?
Yeah, it's tangent.
Oh, okay.
Yeah, but it's like for my work, I got the 2 square root of 2 times square root of 3 over 3. It's just I guess I'll just approach you after class.
Okay.
Sorry.
I know I'm trying to picture it, but yeah.
No, I know, I understand.
All right, I get it. All right. Oh. All right, did we get the next one? Yep, we got that one already. All right. Oops, did I get that one? Didn't realize it was on both sides. All right, so actually now we're going to use the integral of du over absolute value of u square root of u squared minus a squared equals 1 over a secant inverse of u over a plus c. Now you don't really need the absolute value unless there's a chance that it could be a negative number, but if there's not a chance it could be a negative number, you don't really have to worry about that. Okay, so let's say, for example, if we wanted to evaluate integral of dx over absolute value of x times the square root of x squared minus 16. Okay. So the first thing we're going to do is just rewrite again. Actually, you don't have to rewrite because dx is already up there, so that step is kind of unnecessary. Okay, so actually I'll just write it down just so I can mark this one up instead of the original. Okay. So we have our u equals x, or absolute value of u equals x. And instead of here, we have our u equals x there. So you can use either one. And instead of 16, we can just make that 4 squared. And then from there, you just plug it right in. Move that up a little bit. Okay, so we know that the integral is equal to 1 over a secant u over a plus c. Okay. Forgot to mark that one. A is equal to 4. So a is equal to 1/4 secant of x over 4.
Not just secant.
Oh, secant inverse. I forgot something. Thank you. Of x over 4 plus c. Nothing to cancel out or multiply, so that's it. All right. Any questions? Yes.
Would there ever be a time where the coefficient u and the u in the radical will be different?
If it is, you wouldn't be able to use this particular method. Okay. There are some that's completely different, then we'll use different methods. So they won't be as neat as these.
But for now, they should always be the same.
Oh yeah. Yep, for now. All right. Any other questions? All right. Okay. Okay, so let's say, for example, we wanted to evaluate integral of, I'll put that out front, since most of them have them out front anyway. -1 over 5t times the square root 25t squared minus 25 with respect to t. All right. So for this one, I'll just get that -1, bring it out front. Or you can just make it negative. It doesn't have to be 1. Get that dt, bring it right up top. Okay, so 5t times the square root, 25t squared is 5t squared. And 25 is just minus 5 squared. Okay, so we know our a is equal to 5. And our u is equal to 5t. So that means our du is equal to 5 dt. Which means our dt is equal to du over 5. All right, so now you just plug everything in. Okay, so we have our integral, we have our -1, or you can just have negative, that's just fine. Our dt, remember that's 1/5 du. Our 5t, that's our u, times the square root of u squared minus a squared, equal, and that's going to be -1. Nope, forgot to bring the 1/5 down. Bring that 1/5 down, it's -1/5. Times the integral of du over u square root of u squared minus a squared. Okay. Some you'll see with the absolute value over the u value, some you'll see with, so it varies. So they only use it when it's a chance that it may be negative. All right, so we know that's equal to -1/5 times 1 over a secant inverse of u over a plus c. Okay, so we have -1/5. A is equal to 5, so that's 1/5. Secant inverse of 5t over 5 plus c. Okay, so multiply those two, it gives you your -1 over 25. Secant inverse of t plus c. And that's your answer. All right, any questions on that one? All right, we'll do one more. All right, now I'll give you a few minutes to start on this one. So if you wanted to evaluate the integral of 8 divided by 9t times the square root of 81t squared minus 64 with respect to t. Alright, so with this one, if we get our 8, just bring it out to the front. Get our dt, just bring it right up top. We have 9t and square root. 81t squared is just 9t squared. Minus 64, we can just make that 8 squared. Okay, so we know our u is equal to 9t. Which means our du is equal to 9 dt. Which means our dt is equal to du over 9. And our a is equal to 8. Okay, so we just have to substitute our dt. We know that's 1/9 du. Over our 9t, that's our u, times the square root of u squared minus a squared. Okay, so if we get that 1/9, bring it right onto the front. It's 8 over 9 times the integral of du over u square root of u squared minus a squared. Okay, which gives us 8 over 9, 1 over a, secant inverse of u over a plus c. Okay, so we know our a is equal to 8, and our u is equal to 9t. We have 8 over 9 times 1 over 8, secant inverse of 9t over 8. Plus c. We'll bring that up some. 8 times 9 is 72. Well, actually, you don't even have to do that because the 8's cancel out. So you have 1/9 secant inverse of 9t over 8 plus c. Okay. And that would be your final answer. Bless you. All right. Any questions on that one? All right. So that's pretty much it for what